Hi. In this question, we are going to look at a circles problem. If the radius of circumcircle of triangle TPQ, where PQ is the chord of contact, corresponding to point T, corresponding to point T with respect to circle x square plus y square minus 2x plus 4y minus 11 is equal to 0 is 6 units. Then we have to find the minimum distance of T from the director circle of the given circle. Director circle of the given circle. So that is the question. So first of all, we have to understand what is the question saying. So we have a circle, first of all. This is my circle, let's say. The center of this circle is going to be at 1 comma minus 2. 1 comma minus 2. And let's call it O. Now from a point T, we have two tangents drawn to the circle and therefore a chord of contact PQ. PQ, and this is point T, right? Obviously, this line OP is perpendicular. Similarly, OQ is perpendicular. So the situation looks like this, right? So now they have given us that capital R for triangle TPQ is 6 units, which is basically circumradius for triangle TPQ. That is given, and they are asking us the distance or minimum distance of T from the director circle of the given circle. So first of all, director circle of the given circle would be a circle with the same center, but with radius of √2 times the radius of this circle, right? This circle has radius root over 1 plus 4 minus minus, so plus 11. So this is 4. The inner circle, the known circle has radius 4. The director circle radius will be 4 root 2, right? And we have to find the minimum distance of point T from the director circle. So obviously, if you look at the quadrilateral OPTQ, right? OPTQ is a cyclic quadrilateral. Why is it cyclic? Cyclic quadrilateral. Because you can see that two of the angles, angle TPO is equal to angle TQO is equal to 90. So sum of opposite angles of this quadrilateral is going to be 180. So it is cyclic. So therefore, this line OT becomes the diameter of this circle. The circle that passes through OPTQ. Circle through points OPTQ. That circle has OT as diameter, right? And notice that that circle is the same circle that we are talking about. The circle through TPQ is going to be the same circle because there can be only one circle through 3 given points. And here you have 4 points. So basically, that is the circle that is the circumcircle. So radius of that circle is 6. So the diameter OT, since OT was the diameter of that circle, OT will be equal to 12, right? And now the question is done because the distance that they need, the minimum distance from T to the director circle will be this point. The maximum distance would be to here, the minimum distance would be to here. And if you label this as S, we need TS, which is clearly OT minus SO, right? And OT we know is the diameter, so that is 12. And SO is the radius of the director circle, so that is 4 root 2. So that becomes your answer for this question. Now think about what we have done here. There are several concepts. First of all, if there is a circle and if there is a point here and you draw a chord of contact like this, right? And this is the center and this is the T and this is P and Q. You should know that this angle is 90, this angle is 90. And if you join OT, this quadrilateral OTPQ becomes cyclic quadrilateral. And if it is cyclic quadrilateral, there will be a circle passing through the vertices, all the vertices of this quadrilateral. So it is something like this. And clearly that circle is also the circumcircle of TPQ, right? And if it is the circumcircle, OT becomes diameter because you can see angle in a semicircle is 90. And they gave you the radius of the circumcircle, so this became 12. And now all we need is the radius of the director circle, which is root 2 times the radius of any normal circle. Because we saw in the theory, if x square plus y square is a square is the circle, then x square plus y square is equal to 2a square is the director circle equation, right? So this distance is 4 root 2. So the required minimum distance between t and this point is 12 minus 4 root 2. Also, if somebody asks you a question about find the locus of t, right? Locus of t can be also found easily because you can take t as a point h comma k and you can say center of the circle was 1 comma minus 2, and we know that these are the end points of a diameter. We just saw that, right? These are end points of a diameter, so you can say h minus 1 into, no, you have to write equation of the locus. So equation of this circle on which h comma k lies will be, I am writing equation of circumcircle, OTPQ. Circumcircle of OTPQ would be x minus 1 times x minus h plus y plus 2 times y minus k is equal to 0. This is the circumcircle equation in diametric form. And now we also know that this circumcircle has radius of 6, right? This circumcircle has radius of 6. So from there, we can get a condition on h and k. So if you simplify this, you will get x square minus xh minus xh minus x plus h plus y square plus 2y minus 2k minus ky is 0. From here, what we can say is collect all the terms, x square plus y square, you get x terms only here and here, minus x h plus 1, and y terms you get plus y 2 minus k, and the constant term becomes h minus 2k, h and 2k, these are the constant terms, right? So this is the equation of the circle, and we already know radius of the circle is equal to 6. So we can write an equation now saying that h plus 1 by 2 whole square plus 2 minus k by 2 whole square minus h minus 2k will be equal to 6. This is the condition root over g square plus f square minus c is equal to the radius, right? So if you write this condition, this will give us a condition only involving h and k, and this will give us the locus of the point t also. So that is an additional thing. For doing the question, you just need to understand the geometry of the figure and be able to make claims about director circle, cyclic quadrilateral, what is the diameter of that cyclic quadrilateral, what is the diameter of that circle. And if you figure all that out, then the question is done. So hopefully you've understood something from the question. The basic idea is use geometrical conditions, try to use as much of geometry as possible in order to minimize the time and effort that is required, right? If you start writing coordinate geometry equations everywhere, it might become more difficult, right? Okay, that's all for this one. I'll see you next time.